Hello friends, good evening to you all. This is Gurpal Singh from Gursur Education, and today I am going to deliver you the lecture on a non-parametric tests basically. As you all know that we have already gone through from the different concepts regarding the parametric tests. Okay, we have gone through from probability distributions, then I taught you about normal distribution, binomial Poisson we have gone through. Then we did about t-test, okay, which was applicable in case of small samples only. And after that, we did about z-test and f-test and analysis of variance, that was ANOVA. All these tests which we have already gone through falls under the category of a parametric test, okay. And now we have to go for the non-parametric test. Before going through this lecture, I would explain the difference between the parametric and non-parametric test, and after that I shall tell you what are the different non-parametric tests and which are very important from the exam point of view. Why? Because none in detail, none kind of a formula, but still they can ask you about where a specific test can be applied from these given non-parametric tests. So in this way, the question can be asked to you. So in a very detailed manner, we have prepared the lecture on the different non-parametric tests, and the major test is chi-square test. If you would have heard this name in your undergraduation and post-graduation books, okay. From both exams point of view, this question is important. So now I am just going to share the screen and I am going to show you what we have prepared for you in this video lecture. And you have to understand from each and every line I am going to tell you. Okay. So you have to listen to me very carefully so that you can get the complete extreme idea of how the things are going to be done in case of non-parametric tests. So the topic has been written as non-parametric tests, okay, and the first word or name has been written as chi-square test and other tests, okay. Chi-square test is the major non-parametric test. So first of all, I would like to tell the difference between these two kinds of test. What is the meaning of a parametric, okay, and what is the meaning of non-parametric. So we shall be talking about these two terms, and after that we shall be talking about a chi-square and other tests. So suppose there are two populations given, okay, this is population 1 and this is population 2, okay. Let me make a small setting so that I place this here, so each and everything is visible to me as well. So this is population first and this is population 2, okay, population first and population 2. So this is the complete case, okay. And we draw sample from first population. This is sample 1, okay. In the same way, we can choose the sample from any population given under consideration, okay. Let me make it more simple for you. There is a population and you draw the sample from this population. Suppose this is only one population and none kind of other population exists here. I'm going to make it very easy for you, okay. So we have already gone through from probability distributions, namely the normal distribution. After that, we studied about t-test, then z-test, f-test, and analysis of variance, that was ANOVA. And if you remember, we have studied about the different type of assumptions of all these tests, okay. We have studied about these, and in all the assumptions regarding all the tests, we had a specific assumption about the population of the sample, about the population. Do you remember that I told you that the parent population is normally distribution? That was the first assumption in any test, okay. The parent population is normally distributed. This was the first assumption, and the second assumption was the sample is drawn at random, okay. So these were the two major assumptions taken in any kind of test, whether this is t-test, z-test, f-test of analysis of variance, okay. So we took the decision regarding the assumption of the test that this is the population from where the sample is being drawn, that is normally distributed. That was an assumption first. Okay, so those tests, now listen me very carefully, I'm going to teach you those tests in which we take assumption about the population, in which we take the assumption about the population. These tests are known as parametric tests. Parametric tests. Okay, and in those tests in which we do not take any kind of assumption regarding population. Okay, we don't take any assumption. These tests are known as non-parametric tests. Okay, in the exam they can even ask you what is the difference between parametric and non-parametric test. So what I have taught you, just listen to me carefully again. This is a population, this is a sample, and if we take while taking the samples, if we assume something related to the parent population, then this kind of a test shall be known as a parametric test. And if we do not take any kind of assumption regarding the parent population, then these kind of tests shall be known as non-parametric test. And the examples of parametric tests are t-test, then z-test, then analysis of variance or ANOVA. And the examples of non-parametric tests are, major test is chi-square test, and there are number of other tests which we shall be doing in today's lecture. So I'm just going to, I hope that you would have understood the meaning and the difference between the parametric and non-parametric tests. And now you have to understand about the different tests. So first of all, we shall be going for the chi-square test, and this is the major test which is known as non-parametric test as well. So what is chi-square test? So in this way, the chi-square is denoted. Okay, so chi-square is the test statistics which measures the significance of difference between set of observed frequencies and set of corresponding theoretical expected frequencies. Okay, so till now I hope you would have understood the different tests, that whether this is T, Z or F, in which I always teach you that you have to find an observed value as per the formula given in the specific test, and you have to compare this with the critical value given in the table. Only then you shall be able to come at the conclusion whether to accept the null hypothesis or reject the null hypothesis. Okay, I have taught you the complete procedure. Okay, so if there are two samples, okay, sample 1, sample 2, okay, so in sample 1 there are some data points. These can be any, like 5, 6, 8, 12, 20, 25 or anything. Okay, and in the same way there is sample 2, and it can have its own data points. These can be 15, then 20 or anything like that. Okay, and they can have their own frequencies as well. They can have their own frequencies. Both the data series can have frequencies corresponding to their data point values. Okay, so this is the test which compare the set of observed frequencies. What are observed frequencies? Which you find by applying the formula of a chi-square test. Okay, and set of corresponding theoretical frequencies which are already given. Okay, which are available as per the sequence of a chi-square test. Okay, first you observe yourself, second are already given, okay, in the in your numerical or practical. And when you compare these two frequencies, then you can draw the conclusion about the sample, whether they relates to each other or not. So this is chi-square test. So again, if in one line to a layman, if I wish to teach, then what I shall tell, I shall simply say the chi-square test is the test which is used to find the difference between expected and observed frequencies. Expected and observed frequencies. Okay, and While doing this, we do not take any kind of assumption regarding the parent distribution or parent population. So this is why this specific test is known as non-parametric test. Okay. So you would have understood about the frequencies. Okay, frequencies I have already taught you, I think in the first or second lecture regarding the research methodology. So when you are trying to find the difference between observed frequencies and expected frequencies of any sample without any assumption regarding the parent distribution, this system is known as chi-square test. So it is designed as lower Greek letter. This stands for chi. Okay. This is also pronounced as this and this as well. And that was developed by Professor Carl Pearson of England in 1900, which was initially in sociology, then psychology. So nowadays this is used very widely because there are number of populations regarding which we cannot assume anything. And if you cannot assume anything regarding your parent population, then certainly you have to go through for some non-parametric tests, and the major non-parametric test is only chi-square test. So now we move further. So this is a sort of non-parametric test like sign test, rank sum test, rank correlation, one sample. These are some names of non-parametric test which we shall be doing after chi-square test. So that was just a simple description about the chi-square test. Okay. Which are used widely in behavioral sciences, and they do not need any assumption of normalcy about the parameters of the population value. So they do not require any kind of assumption regarding the normalcy or the normal distribution of a parent population. They do not require any kind of assumption. Okay, so that's the major difference between the parametric and non-parametric tests. So we move further. There are some characteristics of a chi-square test which you have to understand, which you have to go through. The first is it is a non-parametric test and it do not require any kind of assumption of a parent population like T test, Z test, F test. These tests take the assumption regarding population parameters, but the chi-square test do not require any kind of these assumptions. Then what it does, its second characteristics is it analyze the difference between set of observed frequencies and expected frequencies. Okay, so this is the only job of the chi-square test. It find whether there is a difference between observed, which we have found, and expected, which should be there. Is there any difference between these two? So what its basic job is to find the difference between these two frequencies. So the third one is, what does it do? It evaluates the significance of a difference between observed and expected frequencies by making comparison between computed value and a critical value. It finds the computed value. So you apply the formula given in the chi-square series, chi-square test, okay, which has already been defined in a very elaborated manner in the notes, and you can go through from UGPG books as well. Okay, so what it does, it simply make the it simply finds the computed value and then the critical value. Where is the critical value? I have told you, I have taught you many times. Okay, each and every test has its specific table given in the appendix of your book. Okay, so chi-square test has its specific table. Okay, there are two kind of values. One the value you find, okay, that is known as observed or a computed value, and second is the critical value, which is given in the chi-square table, and you have to make the comparison between these two values, and only on the basis of this comparison you get on the conclusion whether to accept the null hypothesis or reject the null hypothesis. So this is the process of a chi-square test. Okay, and as usual, there is a concept of a degree of freedom. When you shall see the table on the left hand side, there shall be a separate column known as a degree of freedom or a DOF. That shall be like 0, 1, 2, 3, 4, 5 or anything like that. Okay. And here shall be the critical value assigned corresponding to a specific degree of freedom. Okay. So chi-square test, as usual, the Z test, T test and F test, it also takes into consideration the concept of a degree of freedom. Okay. So this is the complete process of that. So what it does, it uses the one concept as well. The frequencies of the distribution are in original units. Okay, they are not replaced by any relative frequencies or proportional percentage. They simply mean to say the frequencies have to be written like 5, 10, 15, 25 original units. Okay, you cannot like say like 5%, 10% or anything, or proportion like 0.05 or anything else. You have to write the frequencies in a very original units. So this is this is the condition for applying the chi-square test. So till now we have gone through from the subject and concept matter of the chi-square test, and after that I taught you about its characteristics which are important to go through. And now there are conditions. The first was you have to write the frequencies in original units. Secondly, total frequencies in the distribution should not be less than 50. Okay, if these are lesser than 50, you cannot apply chi-square test. Okay, but still there is one formula which I'm going to tell you right now. But the total of frequencies cannot be lesser than 50 in case of chi-square test. Okay, you cannot apply this test when total of frequencies is lesser than 50. Okay, so this is condition. In t-test, what was there? In t-test, the size of sample was lesser than or equal to 30. But in case of a chi-square test, the total of frequencies should be greater than 50. It cannot be lesser than 50. Okay. Then the expected frequency of any item or cell should not be less than 5. Okay, if there are the data points are 5, 10, 8, 7, and their corresponding frequencies have been given like 15, 10, 9. It should not be lesser than 5. Like it cannot be 4. Okay, it cannot be 4. In that case, you cannot apply chi-square test. This is also a very important condition. It's saying that expected frequency of any item cannot be less than 5. Preferably, it should be more than 10. And if it is less than 5, then the frequency of the adjacent items should be added to it by technique of pooling to make it 5. This is simply saying that in case any item is having the frequency of lesser than 5, like 4, then the frequency of adjacent items which are greater than 5, they can be added to this value. Okay, so that its frequencies become more than 5. Okay, so this technique is known as technique of pooling. Okay, so this also take into account the concept of a degree of freedom. So this is again, I'm telling you, the frequency of any cell cannot be lesser than 5, and if this is the case, then you can use the frequency of adjacent items, and these can be added into the item to which there are frequencies less than 5, and its frequencies can be made greater than 5. So this was the third condition. So the next condition is the total expected frequencies must be equal to total observed frequencies. Okay, what you have found should be equal to what is actually there. The total number of frequencies of expected frequencies should be equal to observed frequencies, and this should be the very prime case in for the condition to be applied of chi-square test. So this is about that. The next is you do not need any kind of assumption regarding normalcy of the population value. So this is also the case, also the condition for chi-square test, that you are not supposed to make any kind of assumption regarding the parameters of the main population. So this was the condition number 5th, and no other parameter test like T test, Z test, F test should be applicable to the problem. Okay. So you should, so the problem in hand could not be solved out from T test, Z test, F test. Only then you can apply the chi-square test. Okay. You can apply the chi-square test only on those cases where these kind of tests are not able to be applied. So this is the complete picture of the chi-square test. I hope you would have understood that we have to make the conclusion of what we have studied till now. Okay, so first of all, I told you the difference between parametric and the non-parametric test. So I taught you about these two tests. After that, I taught you about a chi-square test, which is applied for finding the difference between observed and corresponding expected frequencies. For this special purpose, this test is applied. I told you about its brief history. Then I told you some names of non-parametric tests. Then I taught you about the characteristics of chi-square test, that this is a non-parametric test. After that, there is concept of this is used for finding the difference between observed and expected frequencies. Then two values are found out. How? The first is named as computed value, which is computed on the basis of a formula given for chi-square test, and after that there is critical value given in the chi-square table, and these two values are comparison. So after that, I taught you that there are some conditions for applying the chi-square test. The first condition is you have to write the frequencies in original units. After that, the total of frequencies should not be less than 50. And after that, the frequency of any item should not be less than 5. If this is the case, you can add the frequency of adjacent item to the current item so that its total frequencies become more than 5. Then I taught you that the total expected frequencies should be equal to total observed frequencies. And then we talked about that there is none kind of need for making for taking the assumption regarding the normalcy of a population. Then there are no other parametric tests should be applied in the specific case. Only in that cases where the T test, Z test, and F test are not able to be applied, only on those cases the chi-square test is applied. Okay. So that was all about the chi-square test, and I believe you would have understood about this. We shall be talking about non-parametric test in the next lecture. We are going to take in 10 minutes from now onwards. Okay. So that was in detail about the chi-square test. So I hope you would have understood this completely. The note shall be delivered to you, and you are expected to take the next lecture after 10 minutes from now onwards. Thank you so much for joining me in this lecture. This is Gurpal Singh from Gurpal Education.